All right, recording started. Sharing the screen. Okay, good afternoon. Today's topic, we will continue on the single line. Just give me a sec. I think there is a technical issue. Okay, let me share my screen again. Okay, I think last lecture we stopped at the isolators. Okay, so the line isolators. Again, what's the purpose of using line isolators? Is just like to provide a visual. I mean, you can have a visual disconnection from the power. The line isolators are supposed. They are only in either high voltage and extra high voltage. They are not. Well, I'm sorry. I think there's. No, there's something wrong here. Let me do it again. The isolators are not available on medium voltage or low voltage, but they are all of them are available only on the on high voltage and extra high voltage. Okay, where is it? Okay, again. So they are available only on high voltage and extra high voltage, but they are not available on medium or low voltage. And they provide like just a visual disconnection, so as just for extra safety. So the isolators are supposed to be turned on or turned off. They're supposed to be turned off when the current is off. So what do I mean by this? In every like in every circuit, like in the power system or in the substation, there should be a circuit breaker. There should be an isolator as well. So assume you have this scenario, like the power direction goes this way, then you disconnect the power from the circuit breaker. After disconnecting the power of the circuit breaker, which is we call it, the first thing we call it tripping the circuit breaker, what will happen? The current will be zero. Then, number two, disconnect isolator. So disconnect the isolator. So the isolator is supposed to be disconnected when the current is zero. Therefore, it shouldn't provide any flashover or any flash or any spark. So here is like how the isolator is supposed to work. So the circuit breaker first, then isolator. Then again, they're supposed to work when the current is zero. However, some situations can happen, which is basically something we call a circuit breaker failure. So in case of circuit breaker, shortcut CB, circuits breaker failure, this will cause what? This will cause a flash, or we call it spark, on the isolators. Isolators when disconnected. What do I mean by this? The thing, if the circuit breaker is not turned off, which is we'll call it the circuit breaker failure, which is not being turned off, then what will happen? The disconnector will be turned off when there is a current. So what will happen to the contactor of this connector, which basically the air around it will be ionized. Since the air ionized will cause a big spark, as you see in this picture. Like a big spark. What's happened? Why this big spark exists? Because there was a circuit breaker failure. So the circuit breaker didn't disconnect the power. Then after that, we turned off or opened the isolator. When you open the isolator, you will see that big spark that will cause a problem. So therefore, the isolators are being designed to be working only when the current is zero. That's how they are doing it. While this kind of situation is abnormal. This is abnormal because the current does not equal to zero, which is something that we don't want. Now here is an example of the single line diagram. This single line diagram in Jordan for North Amman, محطة شمال عمان, 132 kilovolt to 33 kilovolts. This is in Shafa Badran area. And I would say in Shafa Badran, there is another substation, we call it 400 kilovolt substation, but we don't have it in this line diagram. And so again, in Shafa Badran or in North Amman substation, there is 400, 132, 33 kilovolts. That's what we have. But here is the portion associated with 132 and 33. This is how it looks like. Here is the single line diagram. Then when you look at it, let's start from here. There's something we call a city center, which goes to Wast al Balad, downtown of Amman. Then Sbehi, Rihab, Tariq. And there is another one, Rihab 2, Tariq 1, city center 2, Sbehi 2. So what's the point of adding 1 and 2? Here is like Rihab 2, or here is Rihab 2, and here is Rihab 1, here is Sbehi 1, here is Sbehi 2, and so on. City Center 1, City Center 2, Tariq 1, Tariq 2. Why we have this? Why there is, for example, Rihab, there are 2. Why there are 2 for Tariq and 2 for City Center? Because all of them, they are double circuits. So let me show you this tower picture. When we have a double circuits tower, then there should be circuit 1. For example, assume this goes to Tariq. So this is Tariq circuit 1. And this is Tariq circuit 2. That's why we have 2 circuits. So there's 1 and 2 for the same transmission line. Then let's go back again. Uh-oh.
Doctor, a quick question in isolators.
Yes.
Yeah, are they automatically disconnected when the current is zero?
No, actually, they will be manually. I mean, you can send a command to them to be disconnected. So the point, the circuit breaker will be disconnected in case if there is a power outage, or, for example, if there is a fault, like overcurrents, or line-to-line fault, line-to-ground fault, whatever faults, the circuit breaker will be tripped automatically. While the isolators know, then what's happening when we turn them on, when we are doing a maintenance, in case if there is some maintenance that we need to do in the power lines, then we need to disconnect the isolators. So the first thing, disconnect the circuit breakers. I mean, using the control room, asking the national control room to disconnect the circuit breaker, they will disconnect it for you. After that, you will disconnect the isolators inside the substation. So you will do it manually. It's not automatically. Okay? Does this make sense?
Yeah, sure.
All right, that sounds good. Now again, since the double circuits, like tower or double circuits power lines, it will go inside the substation as double circuits. Now let me start, for example, like in Tariq substation. So you will see different symbols. The first symbol, which is, it has like this earth, or a switch with earth. This thing we call it earth switch. Then the second one, it's still earth switch because it's the same as earth. Then the next one, this parts, it is a switch alone. So we call it, this is isolator. Then the last one here, this is with X, this is circuit breaker. The circuit breaker. Then when you look all of the power lines, they are all sharing the same thing. Earth switch, isolator, disconnector, circuit breaker. Earth switch, isolator, disconnector, circuit breaker. Then the next thing, you will see there are two bus bars. The first bus bar is called MBB, which means main bus bar. Then the second one, reserve bus bar. Reserve bus bar. And you will see it's double bus bar but single breaker because there's only one breaker goes in. Then after that, when you look at the rating currents, which is 2,500 ampere, and the other thing, which is when we look at it, you will see in each power line. Let's go back to Tariq. There is 104, which is isolator. 106 is isolator, while 101, this is earth switch. 101B, earth switch as well. Okay? So now, when you look at it, yes, go ahead.
Why do we have two earth switches for one feeder?
Yeah, I think this is for just extra caution, for extra safety. I mean, not all of the power substations they have extra earth switch, but this is, I mean, like based on the design for just adding more safety. Okay.
Yeah,
Now,
okay.
when you look at it, all of them they are sharing one of these three equipments, which is like circuit breaker, isolator, earth switch. Circuit breaker, isolator, earth switch. Now, if you need to turn off something, you need to keep in mind to work on order. So the first thing that you need to keep in mind, which is turn off, or we call it tripping the power. Trip the power. How to trip the power? Using circuit breaker. The second thing that you need to do, which is disconnect isolators. Then the third thing, do or turn on earth switches. So you need to keep in mind to do them in order. In order. What do I mean by in order? So if you need to disconnect something, the first thing, disconnect all of the circuit breakers. Then after that, disconnect all of the isolators. Then after that, turn on all of the earth switches. Must be in order. You cannot disconnect the isolators before the circuit breakers. You cannot do the earth switching, turn them on before tripping and disconnecting the isolators. Otherwise, it will cause which is called a short circuit faults, line to ground, three-phase to ground faults, which is something that we don't want. So therefore, we need to make sure to disconnect all of the isolators or trip all of the circuit breakers, disconnect all of the isolators. After that, we can turn on the earth switches. Now, before going in more details, what's the point of tripping the circuit breaker? Yes, we need to trip the circuit breaker to disconnect the power. So the circuit breaker purpose disconnect the power in terms of safety, or if there's some contingency, or if there's some faults happening, or the other part, which is when we do maintenance, we need to disconnect the power. The second thing, isolators, they are, as I said, in high voltage or extra high voltage. They just provide extra caution to so you can have a visual disconnection by your eyes. While the third one, earth switches. What's the points of earthing the points or earthing the which is called it the power lines or the electrical equipments. The thing about the power line, as we know earlier, there's a pi model or T model, which is there's a resistance, inductance, and there's a capacitance. When you disconnect the power from here, Um, this does not mean we are out of power because there's some energy stored here. Energy stored. What's the purpose, or where are they stored? Those are stored on the inductor and the capacitors stored here. So the transmission line, there's still some residual power inside it. So if, for example, you need to do a maintenance on the transmission line and you trip the circuit breaker, you disconnect the isolators, but you didn't do the earthing, I mean, the maintenance team will be shocked. This will be dangerous, something that we don't want, we don't like, or we don't want actually, which is very dangerous, that can kill some the crew who are working in the maintenance. So therefore, we need to do the earthing so we can discharge the inductance and the capacitance. So earth will discharge the inductance and the capacitance of the electrical equipments. It can be either the power lines or it can be the transformer, because as we know, the transformer equivalent circuits is an inductance, so it's storing some electrical currents, which is magnetic field and electrical currents. Then we need to discharge it. If you need to do a maintenance on the transformer, make sure to disconnect all of the, or turn off all of the circuit breakers, then disconnect all of the isolators after that, do earthing for the transformer. Otherwise, it will be problem. If you didn't do the earthing, it will be the crew who are doing the maintenance will be shocked, which is will be electrocuted, and it will be can cause some deaths. Okay.
دكتور سؤال مهم بس.
Say that again.
سؤال بس.
تفضل.
هسا أخذنا إشي بالباور سيستمز اسمه الشارجنج كرنت.
اوكي.
هذا له دخل إنه بعد ما نفصل السيركت بريكرز والايزوليترز إنه يكون هو له دخل بكهرب حدا الشارجنج كرنت.
الشارجنج كرنت لما
أنا بعرف إنه هو
صح. When you turn on the power,
صوتك راح.
Yeah, I mean, like when you turn on the power, there will be a charging currents. But when you turn them off, you need to discharge them. So I would say like discharging. Okay. We are turning off the power, so there is a discharging current. So you can say it's a discharging current. Yes, it is. Did you get
it? Okay, thank you. Yeah.
Okay, sounds good.
I also have a question, if you don't mind.
Of course.
Is this also like similar to the 30% rule, where you can't have like PV systems in a transformer neighborhood for more than 50% of the required load? I think it's the same principle, right? Like if you exceed this threshold, you may shock the maintenance crew if they're trying to repair a line or something.
Okay, that's good. I mean, what you said, that's correct, but it's not based on this scenario. I mean, what you mentioned, like if you have a renewable energy at home, here's like your home, there's a renewable energy, and here's the distribution transformer, then it goes to your home, then there is the maintenance crew doing some power here. So they disconnect the power from this side. Then when you are doing maintenance, they're doing maintenance, your home still supplying renewable energy to them, so which will cause the power, which will make electrocuted, or which will maybe make a fault, or will be very dangerous to the crew, to the maintenance team. So what's happening? How can we avoid this issue? The thing right now in the protocols, if there is a power outage, then renewable energy and energy storage systems won't work. Power outage from the grid. Okay, some people can say this is unfair. I mean, here is the photovoltaics, here is your home, and here is the grid. I mean, if you disconnect the grid, you can still be able to supply your home from the photovoltaics. That's theoretically yes, but right now you are not allowed based on our on the configuration. Why we are not allowed to avoid if there is any, maybe the power has been disconnected because of the transmission, or because of the faults, or because of the maintenance. So we don't want you to shake the crew. So here is an inverter, and here's the photovoltaics. So the inverter is being programmed to detect the grid voltage. Detect V-grid. If V-grid 0, no photovoltaics generation. Stop generating power. Okay? And that's what they are doing right now to avoid this scenario that you mentioned. But I would say this scenario is completely independent of what we have here. Why? This substation is based on high voltage and extra high voltage, while this one is based on residential, because here the transformer is 33 kilovolts to 0.4 kilovolts. However, the transformers that we have here, as we will see, based on 132 and 400 kilovolts, which is very different topic. This is associated with low voltage level, the previous scenario, while this scenario is associated with high voltage and extra high voltage. So we need just to make it separate. Each one is different. Okay, I hope this answers your question, right?
Yeah, thank you.
Okay, you're welcome. So again, before moving to the next slide, we just need to make sure to do these three steps in order. The first thing, trip the power using the circuit breaker. The second thing, disconnect the isolators. The third one, turn on the earth switch, which is something we call it as a shortcut, tripping, then isolating, then earthing. That's, their nicknames. TIE. Tripping, isolating, earthing. Must be in order. Let's see another single line diagram, and this single line diagram associated with الصبيحي. محطة تحويل صبيحي 132 33 kilovolts. Here is like صبيحي substation. You will see there's Shtafena 1, Shtafena 2, Amman North 1, 2, Salt 1, 2, Circuit 1, 2, double circuit. Let's look at, for example, North Amman. When you look at North Amman, you will see the same. 401, this is earth switch. 403, this is isolator. 405, this is circuit breaker. And 406, 405, both of them, they are isolators. Then this parts associated with North Amman, we call it line circuits. Then you will see in North Amman line circuits and Salt line circuits, another North Amman line circuits, Shtafena 1 and 2, there's a line circuit each one. Then there is another circuit, we call it transformer circuits. The transformer circuit like this one, the one associated with the transformer. Okay? So again, there is a line circuit associated with the line, like line North Amman North, Salt Sbehi, whatever, Shtafena, whatever we have, while the other one, which is called the transformer circuit, this is associated with the transformer because there's a steps down transformer here. So the line circuit, we already discussed this before, the previous slide, previous single line diagram. Now let's look, let's focus more on the transformer circuits. So transformer circuits starts with two isolators. So as you will see here, there is 416, 414, those are isolators. Then there is 410, this is circuit breaker because it's X. And this is what's called, this is the transformer, step down, power transformer. When you look at it, you will see it is 132 to 33 kilovolts. Okay, step down. Then it is 63 megavolt ampere. And the connection Y to neutral one neutral, delta, and there is no one, which is 1 here, means 1 times 30, which is 30 degrees phase shifts. Since it is y to delta, then it is 30 degrees phase shifts. After that, let's keep going. We need to understand every single detail in this single line diagram. So you will see for 1K0, this is isolator. For BK0, this is another isolator. Then the other thing, for 1K1, for B, for A, K1, for B, K1, those are earth switches. Okay? Then how about those? Those are called capacitor banks, which can supply 10 megavar. Now, my question is, what's the point of using capacitors here? These capacitors, capacitor bank or shunt capacitors, are connected to the power service. What's the point of using these capacitors? What do you think? Do you have any answer?
To lower the, to increase the power factor, so lower.
To increase the power factor, correct. So usually the capacitor bank are turned on during heavy load. As we know, our loads, as we discussed previous, it's RL load. So L is increasing a lot, which means consuming more reactive power, more Q. So this means Q is increasing. Therefore, we can say the power factor equals to be the real power divided by square root of P squared plus Q squared. Since Q is increasing, what will happen to the power factor will be decreased. Therefore, we need to compensate the inductance. As we know, inductance and capacitance are dual, which means the opposite of the inductance is the capacitance. So during this situation, add capacitor to reduce Q. When we reduce Q, will be reduced. What will happen to the power factor? Will be increased, will be improved. So the overall thing about it, which is the vast majority of our loads are RL. Why they are RL? Because the vast majority of our loads based on motors, like air conditioned motors, dryer motor, refrigerators motor. So it's based on motors. Washer is a motor. Then these motors, the equivalent circuit from the motors, you will see inductance, which make all of them are lagging power factor, lagging loads, which make the power factor, if when you have a very large number of motors being connected to power, this will reduce the power factor and will make some problems. Therefore, we need to improve the power factor by adding the opposite of the inductance, which is the capacitor. And these capacitors, they are switched. What do you mean by switch? It will be turned on only during a heavy load. If there is a light load or no load, or I would say like very small value of loads, then they will be turned off. Why? Because we don't want to add too much reactive power into the grid. So we need to make sure this will be compensated, like to make it a balance. Okay? So again, what's the point of adding the capacitor bank? To supply reactive power during heavy load. That's the answer. Now let's keep going, moving here. Then before going left, let's keep going down. There is 41T or 4T1. This is earth switch. There's 4T0. This is called the circuit breaker. Then it will go toward the bus bar, 33 kilovolts. Now, the other thing that we skipped in, now let me go back here, which is a transformer called ETR. What does it mean? This is called auxiliary transformer. What's the point of adding auxiliary transformer, or sometimes we call it zigzag? We already mentioned this before, but just like, recall, zigzag transformer or which like auxiliary transformer, when you look at the rating, converting 33 kilovolt to 0.4 kilovolts. What does 0.4 mean? Which means to 400 volts or 230 volts line to neutral. And what's the purpose of this? To supply power to the grid, to the switch gear. Supplying power or provide power to the switch gear. And substation as well. As we know, the substation, there are some lights on it. There are, like, it's inside a building, the switch gear inside a building. There are some lights. There is, many equipments, electrical equipments that are being used for monitoring. These equipments need a power. How can we supply power? Using the auxiliary transformer. So the auxiliary transformer is a small transformer, very close to the power transformer, the big step-down transformer. But this one is very small in ratings, very small in value. And again, the main purpose for that is to provide power for the electrical substation. That's why we are using the auxiliary transformer, and this is very important. Then after that, when you look at the auxiliary transformer, there is also, switches, isolators, and so on, isolators. The other thing, let's look at the 33 kilovolts. You will see the 33 kilovolts will go through feeders. All of them, we call them feeders. These feeders go toward like several loads, like Karama, Sadd al-Karama, Jordan Valley, Wadi al-Urdun, Jibco, King Talal Dam, Sadd al-Malik Talal, etc. So it goes to different feeders. And you see in each feeder, there is what's circuit breaker and there is an earth switch. Now, my question is, why, when we look at the feeders, there is only circuit breaker and earth switch? While, when we look at those, you will see earth switch, circuit breaker, and isolators. Why here there is isolators? Why in this part 33 kilovolt there is no isolators? Why 132 kilovolt there is isolators? Because again, isolators are only being used in in high and extra high voltage, in high voltage and extra high voltage. That's where are we using the isolators. Otherwise, this is a medium voltage level, so no isolators. Keep this in mind. Now, let's look at, again, the overall. We should now be aware of every single detail. Now, let me ask you something, which is, assume you are a maintenance engineer and you need to disconnect the power or to do a maintenance on TR1. You will do a maintenance here. What label the circuit breakers, isolators, and earth switch that we need to do so you can do the maintenance safely. So let's start with the circuit breakers, then isolators, then earth switches. Keep in mind they must be in order. So start with the circuit breaker alone. Let's look at TR1. Look at the paths of the currents. So there is a path here, there is a path here. When you look at the path here, there is a circuit breaker 110. So therefore, I will add 110 circuit breaker must be disconnected. Now let's keep going. Is there any other circuit breaker here? No. Keep going. Is there any other circuit breakers here? No. Now go down. Is there any other circuit breaker here? No. Go down the other side. Is there any other circuit breaker? Yes, there's this one. So therefore, we will add 1 T0. Now we disconnected the power. The next thing, you need to do the isolators. Now isolators start from the upper path, which is here. Where are the isolators? There is 400, 114, and 116. So we will write 114 and 116. Do you think this is enough? No. Let's keep going down. Go to this side. There is 1A K0 and 1B K0. They must be taken into consideration. Otherwise, there will be a problem. So 1A K0, 1B K0. Now let's keep going down. Is there any path through this isolator? Yes, there is a path. So we need to make sure look at T1 and 1. You need to write it. T1 and 1. Now keep going. We are done with this part, done with this part, done with this part. Going down. Is there any other isolators? No, no more isolators. Now I'm done with the isolators. Let's go to the next stage, which are the earth switches. Look at earth switches. Is there any earth switches here? No. Is there any earth switches here? Yes. There is 1A K1, 1B K1. So we need to label them or write them here, which is earth switches 1A K1 and 1B K1. What else? Let's keep going. No earth switches up. Here we already did those. Then go here, nothing, no earth switch. Go here. Is there any other earth switch? Yeah, there is 1T1. This is the earth switch, 1T1. So we need to make sure to write it. So now, as a result, we just wrote all of the necessarily circuit breakers, all of necessarily isolators, and all necessarily earth switches. Then you can use them to disconnect the power. You can disconnect the power from the circuit breakers, do the isolation, then do the earth switches. Then you're ready to go, and you can do the maintenance. Okay, so it's very important to read this single line diagram, or we call it the catalog of the inverter, or that's single line diagram. Then understand what's going on, and understand and answer if there is a fault happening at a certain transformer. What should I do? There's the other thing, request for the plant outage and switching operation. What's this form? Actually, this is form from the real life forms that I used when I was part of NIPCO. Even like you see, it's in 2016. So what's the point of using this? In case if there is something urgent or scheduled maintenance, we will use this. Now, assume there is one line on the, or there is one tower, tower number, for example, 20 on the circuit number 2 between Amman North and Sbihi. We need to do a maintenance to fix that tower, or fix there is an armor rod. We need to replace an armor rod on the conductor there. So what we need to do before doing anything, the first thing that you need to do is to write the switching request to make sure, is it okay to turn off the power on that line? Do you think the power or there is a sufficient power to supply the load when we turn off the power, this line? And as we know, this is, each conductor, there's one and circuit 2. So here is a substation, for example, Sbihi, here is substation North Amman. Then there are 2 lines. So assume that we need to do a maintenance on circuit number 2, which make it out of service. Now, the question is, do you think circuit 1 is capable of handling all of this amount of power? Yes or no? We don't know. How can we know that? We will write the requests on Planet Outage that will go to the operation department, operation manager. They will do their economic dispatch. They will do a power flow and optimal power flow to make sure that we can disconnect the power safely without noticing any power violations, and also maintain the least cost operation, which sometimes if you disconnect the power during the rush hour, which will cost a lot of money. It can cost thousands, several thousands, and this outage. Therefore, they will look at what you need to do. What's the point? Is it urgent or scheduled? The other thing, they will look at the time of the day. For example, this one is scheduled on Thursday between 10 o'clock a.m. until 12 p.m. So they will monitor the load in this situation, and then they will send a decision by approved or not approved. If approved, then you are good to go to this. If it is not approved, the thing here, they will ask you to reschedule it on another time. So you can reschedule it during off-peak periods or during holidays like Fridays or etc. So whereas the load will be very light, then even though if you disconnect the power from circuit 2, circuit 1 will be capable of handling that amount of power. Then we need to make sure, again, to make sure to send this request to two departments. The first department, which is called the which is the Power Operation Department. The second department, which is called NCC, which is National Control Center. So they will be sent to be two things, which is Power Operation Departments. Power Operation, the departments that they are doing the which is called the security analysis or economic dispatch power flow and optimal power flow. Then the other thing, it will go to the National Control Center, which is basically NCC. This is very important, and I mean, to go to NCC, I mean, the operation department will send the approval if yes or no, while the NCC is monitoring. If there's some other maintenance on the power lines, they will say like, okay, schedule yours in different time because we already have, I mean, a lot of maintenance, a lot of power lines that are, I mean, under maintenance. So this will cause insecurity or will cause several, it can cause a problems. Therefore, we need to disconnect it in different time. Okay? So when you look at it, you will see the reason for the outage, which is, for example, to install Alma Road. Now, what we need to do, just make sure to fill the circuit breakers numbers and the isolators and the earth switches. Now, what should I do? I mean, how can I fill them? We already have the single line diagram of each substation. Now, by the way, we will do it for circuit number 2, North Amman, Sbehi. Now, let's go to substation of North Amman. This is North Amman substation. Now, let's go to Sbehi number 2. Where is Sbehi number 2? Here. When you look at the Sbehi number 2, don't look at the transformer circuit. Look only at the power circuits. This is the power circuit. When you look at it, where is the circuit breaker? 805. Therefore, you will go here and at North Amman towards Sbehi, you will write 805. Now the next thing for Sbehi, again, don't do the isolators and the earth switches now. No, you need to be consistent, which is first of all, turn off the circuit breaker on Amman North. After that, turn off the circuit breaker on Sbehi. After that, turn off the isolators on North Amman. After that, turn off the isolators in Sbehi. Then the last one, do earthing in Amman. After that, do earthing in Sbehi. So we need to be consistent. I mean, you cannot skip one step or like work, too fast on one substation and not working too fast on the other substation. So keep in mind, again, we need to make sure, go here like to Sbehi. Let's go to Sbehi substation, the Sbehi substation. Look for Amman North. Again, we will look at the line circuits. Don't look at the transformer circuit, just the line circuits. When you look at the line circuits, here it is. Where is the circuit breaker? Here's the 405. So basically, you will erase it and write here for 405. Now, we are done with the circuit breakers. Let's go to the isolators. Isolators, let's go to Amman North first. Here are the Amman North. Then the isolators associated with Amman North are basically 803, 804, 806, no other mores, no mores, while the rest are earth switches. So it will be 803, 804, 806. Then the next one, Sbehi. Go to Sbehi substation here. And in Sbehi, where is it? Here's Sbehi substation. You will go toward Amman North. Here's Sbehi substation. Look at the line circuits. Again, like this is 403, 405, 406. Then you can write them here. 403, 405, 406. Once we are done with the isolators, let's go to the earth switches. The earth switches, here, when you are in Amman North towards Sbehi, you will see the earth switches are 801A, 801B, 801C, 801D. So 801. So as a shortcut, I wrote it as 801. But if you want to write it as 801A, 801B, 801C, then you are good. The other thing, Sbehi substation, which earth switches? Here is Sbehi substation. You will go toward North Amman. The only earth switch, which is 401. And that's it. So you will see in Sbehi substation, it's written 401. Okay, now we are done with everything here, almost everything. Then the next thing, here's the earth switches. Like the duration of the outage, you need to tell them like in details when it is gonna happen, how long it's gonna take. Then there is something we call it emergency restoration service. Here we wrote it as 1 hour. What do I mean by emergency restoration service? Which means assume there is something wrong happening in the power line, and we need to turn on the power that you are working on, the power line that you are working on immediately, as soon as possible. So in order to do that, I mean, you cannot do it immediately. Actually, they will ask you to do it immediately, but you cannot. So you need, it will take some time to disconnect the power, to let the work team stay away from that. Disconnect, not the power, I'm saying disconnect the earth switches, and let the team go away from the power lines, and then therefore you can do the maintenance, or you can, make the emergency restoration back. So here we wrote it as 1 hour. So when you call me to make a power restoration, give me 1 hour. It's gonna take me 1 hour. Sometimes we can write it as half an hour. So if you need to turn back emergency restoration, you have half an hour to set everything up. Then we can go back in service. Then here is again, this is for the National Control Center, مركز المراقبة والتحكم. Then they will judge based on that. Okay, any question? Now, what we know so far, we know how to disconnect which is called a line or power line using line circuits. Then the second thing, how to disconnect the transformer from the transformer circuits. Okay, so from transformer circuits, how to disconnect the power. Keep in mind that when you disconnect the power from the line circuit, the same thing that we did here exactly. While if you disconnect the power from the transformer circuits, do the same thing that what I wrote here. Circuit breakers, isolators, earth switches. Any question on the single line diagram?
دكتور أنا عندي سؤال أغلبك.
تفضل.
أنا دكتور إحنا عندنا مثلا بنورث عمان في عندنا اللي هو 4 إيرث شوي ولا؟
بالله ما سمعتك، في مجال تعيد السؤال.
إنه في عندنا 4 إيرث بنورث عمان، فما بيكون كوست شوي هذا على شو اسمه؟ ما بيكلف؟
هو بيكون مكلف صح، بس مرات هيك التصميم اللي اجى خلاص ما بتقدر تحكم، هذا موجود هيك. الافضل نعمل ايرث سويتش واحد اكيد زي ما عملنا بصبيح، بس هون نورث عمان محطه كبيره والاكويبمنت اللي فيها غاليه كثير ومهمه، فبالتالي حاطين اكثر من ايرث سويتش.
أوكي. شكرا دكتور.
عفوا. Is there any other question? Again, the expectation to understand every single detail. So if I ask you what's the capacitor bank, what's the purpose, you need to have an answer. If I ask you disconnect TR1 from service, you need to know how to disconnect it, or disconnect, for example, like North Amman and Shtafena, circuit number 1, you should be able to do that. So you will have, the circuits, which is called the single line diagram that we have here, will be provided. So don't memorize it. It will be provided either in the exam or whatever, so that it will be provided. Then, so don't memorize anything from the single line diagram. But you need to understand what every single detail mean. What's the auxiliary transformer mean to supply power for the substation or the switch gear. So you need to understand every single detail. It's very important for you to understand, so you can solve it. The other thing, you can write how to disconnect the line circuits or how to disconnect the transformer circuits. Here is an example. So in the example, giving single line diagram of, it's a practice, by the way, it's a homework. and I will make the due dates is on Thursday. Due on Thursday. So on the exam day. So what you need to do, assume you are working in the electrical power company in the maintenance departments, and there is a small cut in the conductors at circuit 1 of Salt Sbehi, 132 kilovolt transmission line at tower number 25. You need to install armor rod as an urgent action. You decide to take its maintenance on October 31st between 10 a.m. to 12 p.m. As an engineer, write the switching form. So I will need you to rewrite this based on the new information, based on the 10 a.m. to 12 p.m. October 31st, and based on what's called, I think, what's the circuits? Working on the Salt Sbehi, yes, Salt Sbehi. So just make sure to write Salt Sbehi. Then you need to choose the corresponding values of the circuit breakers and the isolators. So by the way, you can go, I mean, here we are done with this chapter, but this is homework. You can submit it on Microsoft, in the e-learning as we used to do. By the way, there is one file when you go to the Microsoft Teams, you will see a folder. You will see a folder. It's called switching. That folder switching has several single line diagram of several substations in Jordan. For example, the Sbehi, Suwaym, Salt, South Amman, Madaba, Broadcast, Sbehi, etc. So you will see, for example, here is like South Madaba substation. This is how it looks like. Each single line diagram of each substation, we already have it. And here's single line diagram Amman North, and so on. So again, there are several single line diagrams that you can use. Then you will see, for example, Salt and Sbehi. Here's the single line diagram of the salts. Single line diagram of the Sbehi, it's already been provided before. In case if you don't have it, you can go back to this folder and see it. Here's the Sbehi. The other thing, assume here are two examples, like Amman North Sbehi, circuit number 1, Amman North Sbehi, circuit number 2. So here is an example of circuit number 1 between Amman North and Sbehi. Then you can, validate this by looking at the circuit breaker numbers, isolators number, the isolators, the air switches, all of them really matters for us. Then the other thing, assume this scenario. What is the other scenario? Salt Sbehi 2, yeah, then you can fill it. So what you need to do is to use this form. It's already been in Word file. Then you can use it, modify it based on the exercise, then save it as a PDF and submit it on the e-learning. That's the expectation that you need to do before Thursday or by Thursday at max. Again, this is very important in the test. And you will see it definitely in the test. So if you didn't know, if you didn't master it, you need to master it right now before it's being too late. Okay, any question? Again, please make sure to understand this very well. Now let's move to the next part, which is the transformers. But by the way, from now, transformer is not included in the first exam. So the first exam ends by that practice. Now this is part of the second exam material, okay? So the first exam includes file number 1, 2, 3, while number 4 will be on the second exam, inshallah. So transformer. So what's the point of using the transformers? The transformers, we have two types. There is either step up or step down. The step up transformer, we call it generator step up. And sometimes we call it as GSU. GSU, which means generator step up. Generator step up, this is GSU. So GSU transformer, it is very common and used a lot. And of course, it's happening after the generators. So we need to step up the voltage to reduce the amount of losses. And there is a lot of money, spending a lot of money in investing and how to improve the transformers. And by the way, you might be surprised, but the total investments in the transformer may exceed the generator investments. So investing in improving the transformer, they're spending more money, more efforts on in improving the transformer more than in improving the generators. Transformers are extremely important, especially like when they transmit the power from one side to the other side. The transformer is considered as an electrical machine. So the electrical machines can be static or dynamic. The dynamic, which is the things that we know in motors and generators. While the static, which is transformers. Okay, so again, it can be either static or dynamic based on whatever needs. So the transformer is an electrical machine, but there is no moving parts, and it is transferring the energy from one side to the other by the electromagnetic induction. Because like this, by electromagnetic induction, then transfer the power from here to here. And there is external cooling might be included to avoid any heat exchanges, like radiators, fans, oils, and pumps. Radiators and fans are evidence, like in this figure as we'll show you. The large horizontal tank at the top, which is called a conservator. So what's the point of cooling the transformer? Again, it is power transformer. We will focus more on the power transformer. For the power transformer that can handle up to 63 megavolt ampere, there will be some losses, like eddy current losses, So these losses will be transferred or will be translated as heat. If it is getting too much heat, we need to cool it down. How to cool it? There is an oil. That transformer will filled with oil. So the oil will work to cool it down, filled with oil. And insulation material as well, filled with oil. The other thing, you will see some fans here. Use fans to add extra type of cooling. And there is another one, which is, so call it the reserve water. Where is it? Conservator, I'm sorry. The conservator here, there is some oil tank. It will be as a backup. If there's some oil reduction inside the transformer, then the conservator will supply more oil to the transformer. Okay, so this is again the power transformer, but this part is called GSU, generator step-up transformer. This is step-down transformer, which is called like step-down power transformer. It's a power transformer. Yes, it is a power transformer, but it is stepping down. Here are another pictures for the transformers, as you can see. So you will see there are some fans here cooling. Here's like conservator. This is called the main tank. Okay. Now here is how the coil inside it, the structure inside it. You will see there is like some windings. These windings, or we'll call it like the coil. There is, which is we call it core, which is a ferromagnetic material, and there is a coil, which is a number of turns around the core. And it is very useful for the as an induction taken from one to the other side. Transformers are typically used because there is a change in voltage, which is either step up or step down. GSU, which is generator step up transformer, and there's a power transformer for step down. The power transformers are already being defined that have a ratings 500 kilovolt ampere and larger. That's how we define it. Purpose of the transformer. What's the point of using the transformer? As we know, the first thing to reduce the conductor cost, because when we step up for the same amount of power, the voltage will be high, the current will be low, then less amps. What does it mean? It means less cross-section area. Cross-section area. And what does it mean? It means, less cost. Less amps, few currents, which will make less cross-section area of the conductor. Then you will save some money. Minimization the power losses, because the power losses equals I squared times R. Once you decrease I, what will happen to the losses? Will be down. How to increase I? By increasing the voltage. Increase the voltage will decrease the currents. The other thing, enhancement the transmission line efficiency, because the overall, if you didn't step up the voltage, there will be a lot of losses. And so many losses will be inside the power line. Therefore, we will need to increase the efficiency by adding this. Transformers are basically on a constant wattage device. This means the voltage multiplied by the current must remain constant. Therefore, as I said, P equals, or S equals V times I. This S must be constant. The transformer cannot supply power from nothing or provide power from nothing. So it must be constant. Therefore, when you increase the voltage, what will happen to the current will be decreased to maintain a constant relationship. The transformers transfer the electrical circuits from the other side from one side to the other side. If you increase the voltage, will be step up. If you decrease the voltage, will be step down. So higher voltage and lower current reduces the size and the cost of the transmission lines that we already discussed. Transformers made possible economic delivery of the electrical power. This makes the again the transformers a good solution, especially in AC. The transformers, they don't require as much attention as the other equipments, but we need to make sure to do the regular maintenance and do the extra care regularly. Otherwise, it is not very critical. The problems of the transformers are not common. The common problems that are associated with the other things, with the other electrical equipments. While if you assume everything is okay of the transformer, the design is fine, you will not see a big uncertainty. Here is like the ripple of the operation. Basically, here is the transformer looks like. There is a core, and there's a primary winding and secondary winding. Then the current going here inside the primary, and the currents across the secondary will be produced because there will be a flux. There is a flux and there is a current going on. This will produce a current in the secondary side. And again, there's a flux as well. So the flux will go inside the core. We need to make sure it can handle that much of flux, that can handle that much of current. Otherwise, it will cause a saturation, which will be a very big problem in the power lines, especially like the transformer saturation. So the core, which is basically made from very thin steel lamination, coated with insulation. That's the best scenario. The insulation between individual laminations losses are reduced. The steel core provides a low resistance path for magnetic field because it's being like as a slice, very thin steel laminations, which is, I would say, like a very thin slices of steel. Classification of the transformers. The transformers can be categorized into several types according to several specifications. The first one, single phase and three phase transformers. Single phase transformers convert from one voltage to the other one. Three phase transformers is the same, but depending on the number of phases. So here is an example for the three phase transformer with no neutral. 1, 2, 3, phase A, phase B, phase C. While the next one here, this is phase A and there is a neutral. So this is called the single phase. So this one is a single phase, while the other one is a three phase transformer. Okay. Any question? All right, now classification based on the service. So we have based on the service like something is called power transformer, distribution transformer, instrument transformer, and the grounding transformers. Power transformer, this has the largest capacity, very large in capacity, very large in size and capacity. So those are the main transformers are used for stepping up and stepping down the voltage levels. So the power transformer can be either indoor, outdoor, or indoor-outdoor type, and they're classified as a high voltage system equipments. And the other thing, which is we call it generator step-up transformer, which is basically part of the power transformer. And here's how it looks like. This is called a power transformer. It is very big, bigger than the classroom. Power transformer. Here's how it looks like. It's very big in scenario. This is also the power transformer as well. While there's another one, distribution transformer. Distribution transformer are basically is being used to convert 33 kilovolts to 0.4 kilovolts, or 33 kilovolts to be, or 11 kilovolts, I'm sorry. 11 kilovolts to 0.4 kilovolts, which is basically is used to convert medium voltage to low voltage, which is basically step down. Why it's called distribution transformer, we already mentioned this before. It will supply the power directly to the customers. And there must be 4 wires, there must be A, B, C, and a neutral, because we have some single phase loadings for the other customers. Therefore, we need to make sure those are transformers, which is called distribution transformers. So any transformer smaller than 500 kilovolt ampere, this is called distribution transformer. Any transformer larger than 500 kilovolt ampere, this is called power transformer. Keep this in mind according to the ratings. Even though they can maybe share the same principle, which is stepping down, but the distribution transformer is not called a power transformer because the rating is below than 500 kilovolts. So again, if it is below than 500 kilovolts, kilovolt ampere, then we will say it is distribution transformer. So as a shortcut, DT. DT, distribution transformer. Take the first letter, DT. We denoted it already. The distribution transformer can be either pole mounted or ground mounted. So pole mounted or ground mounted. So here is an example of pole mounted. It can be pole mounted if the rating is below than 250 kilovolts ampere. It is pole mounted. And it can be ground mounted. Here's again pole mounted again. It looks like the pole mounted into the pole. Again, this is associated with the distribution transformer. And there is a ground mounted. Maybe I don't have the image for the ground mounted, but the ground mounted on the ground will be larger than 250 kilovolt ampere, but it will be less than 500 kilovolt ampere. So depending on the current, if the current is too large, then basically we will use the power is too large, we'll use a ground mounted. Here is a pole mounted. And again, distribution transformer is being used to convert medium voltage to low voltage. It's only for that. And it is pole mounted if it is below than 250 kilovolt ampere, or it can be ground mounted if it is mounted between 500 kilovolt ampere and larger than 250 kilovolt ampere. Okay, so here's like some schematics about each one. This is again how the distribution transformer looks like as a zoom. You will see it is very small in size, smaller than the power transformer. Okay. Now here's the instrument transformer. Let me stop here. We will continue inshallah on Thursday. Any question? All right, so I'm stopping here. The instrumental transformer. Okay, where is it? Sorry. Stop recording.